Welcome to this webinar on sensor correlation. Uh, the reason why you're here is probably you believe that dynamic sensor correlation is needed at every mill to ensure that your online QCS sensors match your offline quality measurements. So I'm so glad that there are so many people interested in the subject. Hopefully you have a lot of takeaways by the end of this webinar. So during this presentation, I would like to address a few important subjects, such as what is sensor correlation? This is pretty important. I want to make sure we all have the good understanding of what it is and why it needs to be done and why it is so critical to the paper makers. What kind of economic impact it has on you. And then how about problems affecting sensor correlation results? Why are you having challenges achieving consistent results? I'm sure some of you probably brought that question with you. And then how about how to set proper correlation expectations? What is good enough? At what point you have to make a change to the sensor to make sure it matches the lab. We'll be talking about that as well. And then some best practices for sensor correlation based on TAPPI standards. This is what we go by. And then also what ABB, what we can do to help you. So hopefully you have a good time here in the next hour. So we talk about the value. What is our value proposition for for sensor correlation? So we know that proper sensor correlation, it improves quality measurements accuracy, and it enhances paper machine performance. You will see great, savings in raw material usage, reduced rejects, and energy consumption, which lead to increased profit. And how about reduced customer complaints? And that's really huge too. So I had a visit to a customer site on the West Coast, and I was working on their moisture sensor correlation program. And it turned out that the moisture was reading about 0.5% higher than the lab. So when I was leaving the site, the mill manager actually came to me and he said they could have saved about $10,000 a month just on steam usage alone with accurate moisture measurement. So that was pretty significant. And then later on in this webinar, I'm going to show you how you can, objectively calculate your potential savings if you were to reduce your measurement error. So if you have an accurate measurement. So this is an interesting part here. So before discussing anything related to sensor correlation, it's really important to understand what sensor correlation means in the paper industry. You won't believe how many people confuse the terms of sensor calibration with sensor correlation. So it's really important to differentiate between the two terms. So let's talk about calibration first. Calibration is just a comparison between a known measurement, which is our calibration standard, and the measurement using your instrument. So it's measure the input from a standard source, and you control the output so that the signal being output is accurate and repeatable. So interestingly, calibration has little or no association with measuring a specific paper maker's product. You might be a little surprised here. So for example, the calibration of a caliper sensor, it compares its response to standards that have known as thicknesses. Once the relationship between the caliper sensor response and the standard is known, the calibration process is complete. You look at this, we haven't even touched the paper yet. We're only calibrating that sensor. And once the sensor is calibrated, we use a set of external static check samples to verify the stability and the repeatability of the gauge. So typically you see your QCS maintenance service provider to perform monthly check samples. So here we're only testing the stability and the repeatability. So that's the calibration. Okay, what about correlation? In the paper industry, this usually means comparing online sensor measurements with offline measurements that's made in a quality control lab or a scale, if we talk about basis weight correlation. So in this webinar, I'm going to be mentioning the term online sensor. That's the sensor I'm referring to that's inside of a scanning platform. Okay. Well, we all know if you have two watches, you don't know what the right time is, right? So we have the lab and we have the online sensor. So the usual method for correlation analysis is we perform a two-variable regression. Okay, this is similar to the concept of independent and dependent variables. So here we make the lab the standard. Okay, and then we adjust the online sensor to match the lab measurement. This is our goal here. Okay, so as you can see that the calibration and correlation are two different terms. So calibration has to be done before correlation. And you also need to make sure that your lab instruments have to be calibrated to a traceable standard, such as the NIST, so the National Institute of Standard and Technology. So you make sure your lab equipment is calibrated. So we also, hopefully you understand that a calibrated sensor doesn't mean it's a correlated sensor. Is that pretty clear? There's going to be a test later on to see if you remember this. I'm just kidding. Okay. So I talk about the difference between calibration and correlation. If you want to know a little more, you want to read a little more, here's a really good TAPPI publication. You can record, write down that name, and you may recognize some of the authors here, such as Terry Figo with International Paper Corporate Technology, and Steve Sturm, who used to be a physicist working for ABB. So this book will give you some really good information on sensor calibration and field correlation. Okay. So Chris said earlier, we're going to be having some polling questions throughout the webinar. We want to keep you awake, and we also want to collect some information. The real reason is we want to see what you are really thinking about, what your understanding is for the, there we go, for this concept. So I would like your honest answer. When you came to the webinar, what are your thoughts? So if you would, here, a paper testing lab is unnecessary if you have a QCS scanner. A true, B is false. Please, I would like your full participation if you could. Please give me your answer, your honest answer here, because in the field we have seen both. I mean, we've seen actually a lot of paper makers, they do think that we don't need a lab, we got a QCS scanner. Okay, so the poll has ended. Can we review the results? Did everybody answer? Okay, I see some, well, most of you answered false, and we still have some no answers. So if you would, please, I'd like to have your answer here. It doesn't take very long. It's A or B, false. I promise you all of our polling questions are pretty simple. All right, thank you. Thank you very much. So, we have seen many paper quality lab tests either eliminated or downsized over time to reduce costs. So some paper mills think that because they have a cell by gauge program and they just rely 100% on the scanner, they don't need to do any lab testing to verify the online measurements. Okay, so there's still a lot of that understanding out there. So, I have explained earlier the difference between the sensor calibration and correlation. And the online sensor provides continuous dynamic measurements, but it's influenced by the environment, the source decay, like for the basis weight sensor, and your paper process furnish. So you absolutely need the offline lab to correct the online sensor measurement. So it's really a system of check and balances. And the sensor correlation validates slope and offset, in your product code setup, if you know what I'm talking about. All right. Now we know we need to do correlation. How do we do it? So there are a lot of different sensor correlation methods depending on the process, the paper properties, the location of your online sensor measurements, and the type of lab equipment. So a variety of sensor correlation methods can be chosen from, and here's a list of some typical methods that we use. I'm not going to go into the details for each method, because we don't have enough time. I'll just point out a couple, commonly used ones. So for example, the first one, real weight or roll weight method. So this is the best method for basis weight correlation. Why? Because you weigh the whole reel. You take the scale weight, the trim width, your linear footage, and you calculate the average basis weight for the entire reel. That's your sample. You're sampling the whole reel. And then you compare that result with the reel report. So that's the basis weight average for the whole reel. So this gives us the most accurate reading for basis weight. How about single point? Just before you turn up a reel, the scanner head package is put in a single point position, and a calibrate sample is performed at the scanner. At that time, it will collect the average measurements during the calibrate sample time, and then report the results as a sensor measurement. So after the turn up, multiple samples are cut from the reel, at that single point position. If you notice, I said multiple samples. I've seen some mills, they only cut one sample. What if they have a sample, taking error, and they want to use that one data to compare with the scanner reading? So you need at least 2 to 3 samples here for real. And then, so this is a really commonly used method, the single point, and you can use that for all of the paper properties. You just take the sample from the paper, and then you measure in the lab, in the lab. So what about the strengths and weaknesses? So the strength is, it's a simple process if your standard operating procedure is followed. It's a big if here, okay? I've seen a lot of paper testers, they don't follow the standard operating procedure. I'll talk a little more about that later. What are the discrepancies, where the source of the error comes from, and also, are they validating the results? So if they take 3 samples from a reel, are they just simply averaging them? Do they even look at the data? If you take moisture, if you take 2 samples from one reel, the moisture, the 2 numbers you calculate from the lab, they have to be within 0.2% of each other. So you validate yourself, validate the results. If they're way off from each other, you don't want to average them and use that to correlate this online sensor. Okay, so but how about the weakness? We know the sample conditioning error. A lot of the paper makers, they cut the samples, they really don't put them in the bags right away. They put them under their arm and they walk around the machine floor, talk to all their buddies, then they go into the lab. And finally, it took a long time to finally get the lab results. So I think that's going to be accurate. Okay. I think maybe I gave away the answer for this question. So poll number question 2. Which of the following is the main source of any discrepancy between online sensor measurements and the lab measurement? Again, I would like your full participation and I would like your honest answer. Don't just pick your answer based on what I was saying earlier. So based on your experience, is it A, the lab equipment, B, the scanner, or C, the paper tester? So you have we'll give you about 30 seconds to answer this question. It shouldn't take long. You should know that right away. And I want to look at the results to see if the results really match what we normally see in the real world, in the paper mills. Because, we get plenty of phone calls from the lab or the machine operators, they call us, they say, well, the moisture is off by 1%. Can you check the scanner? We hear that all the time. So in many paper makers' mind, the only contributing factor to a discrepancy between the lab and the scanner. Must be the scanner. So I'm really curious to see what your answers are here. Okay, I think it ended. We can reveal the results. Are we going to be able to see that, Chris?
I don't know what happened here.
That's okay.
You can't
We'll
see
move
them.
on. I will see your results later. But so, you know, I'll talk about the error, where that comes from later on. So, we hear that a lot. So this is myth number 2, is always the scanner's fault. We hear that a lot. If we have some field service engineers on the phone, I'm sure they're nodding their heads right now. All right, so let's talk about some typical problems affecting sensor correlation results. Why you have a hard time achieving consistent results between the lab and the scanner. Okay, so we have these 3 categories: the paper mill lab test, the paper making process, and the sensor. In each category, there's multiple things that can affect your sensor correlation results. Okay, I just listed a few examples. So for example, your procedures don't follow the TAPPI standards. So for example, the TAPPI standard shows the drying for moisture test. The drying oven temperature should be set at 105 degrees Celsius plus minus 2 degrees. Okay? You won't believe how many labs I've been into. Either the oven does not have a thermometer, or they set it to a wrong temperature, or in fact, I've seen even a lab setting the oven temperature at 105 degrees Fahrenheit. So they'll be drying the samples for a little bit. Okay. How about the paper testers don't follow their standard operating procedures? We talked a little bit about that earlier. How many of you have seen the oven? You open the oven, you see, oh, there's a pizza in there, or they're roasting peanuts. I'm sure that's not in the TAPPI standards. Okay, so that oven condition definitely affects your paper condition. One time I left the paper samples in the oven overnight, and guess what? The next morning when I weighed it, it gained weight. So I don't know what happened overnight there. Okay. How about improper correlation method used for some sensors? So for example, if you have tissue paper, you do not want to use the single point method to do your weight correlation. What's weight? That's weight per unit area. That's basis weight. So because of the elasticity of the tissue paper, it's hard to determine the area of the tissue paper. So you're not going to get an accurate measurement of the area. So you will not get an accurate measurement of your basis weight. It's better to use that real weight method in this case. Okay. Then how about the two-sidedness? So we have a wire side and a felt side. When measuring the samples cut from a reel in the lab, you better be careful, how the samples are oriented, so that you know which side you measure. Because, for example, you have smoothness, gloss, fiber orientation, all of these paper properties. They could be different for the 2 sides. Okay. How about your lab equipment not calibrated? That's a big thing. If you don't calibrate your lab equipment, how do you expect that you're going to use that to correlate the sensor? Okay. And then the paper making process. We know that the high process variability, that can increase that deviation between the lab and the online sensor. It's hard. It's hard to measure and collect samples in the same area of the reel. So you may be comparing apples with oranges when you do the correlation. Okay, how about the online sensors? Well, they're not perfect. So some online sensors are not calibrated, or they're not accurate or repeatable. So they are incapable of producing reliable measurements for correlation. So one time I was at a tissue mill, I saw that the moisture measurement was negative. Yeah, that was a little hard to believe. So I asked, why is that negative? After doing some investigation, it turned out that they had replaced that moisture sensor, but they did not put in all the calibration constants. So it really tells you the sensor was not correlation capable. It's not even calibrated. So that could be a contributing factor of your correlation results not being consistent. So these are the three areas I just want to point out, some typical effects, typical reasons. Okay, so where does the correlation variance come from? Okay, not just from one area. So it comes from these three areas: sensor accuracy, the process variations, and lab test accuracy. All of these variabilities will impact your sensor correlation results. So I'll show you a case study with a customer's challenge for an example. So this customer, they couldn't achieve repeatable coat weight correlation results between the lab and the online sensors. But guess what? They assumed the only contributing factor to this problem was the online sensor measurement. And they said, it's got to be the scanner. So, our team went in, we did a lot of work there. So we have conducted sensor verification tests and proved that the online sensors were producing repeatable and reliable measurements. So that was really not the cause of their discrepancies. And then we found out that the majority of the error between the sensors and the lab, that came from the machine's high process variability and their inconsistent lab results. Right. So here's our case study here. So let's take a look at this process variance. So we put two scanners in the single point position and collected basis weight measurement data. So as you can see in the left chart here, the basis weight really presented high short-term variability. So this is about 5 pounds peak to peak here we're looking at. And we're collecting samples at 5 seconds interval. So that's really, really high, 5 pounds. That's a lot for short-term variability. Then a week later, they found out that they actually had a wet-end process issue. So after they resolved the issue, if you look at the chart on the right side, actually the peak-to-peak value reduced significantly down to 1.3 pounds peak to peak. So wouldn't you think that this kind of high process variability will impact the correlation results? Absolutely, yes. Okay, so then we continue. We say, okay, we had process variability. What about the lab? Okay, so we started following the lab, people, see how they take samples and how they calculate the results. So we also wanted to, take samples to check. We wanted to check the variability ourselves as well. So what we did was we took samples from 3 locations of a reel, front, middle, and back. Then we cut 3 paper strips, in the machine direction and in the cross machine direction in each area. And each paper strip was about 1 inch wide by 3 inches long that weighs about 13 grams. This is the sample size that the mill was using for this calibration, for correlation. And so we thought, okay, we'll use the same sample size. And we wanted to see how repeatable the lab results were from these adjacent paper strips, because they were right next to each other. That's how we cut them. So then the lab test really showed us some really amazing results. So just from these adjacent strips, we have seen the lab test showing the actual coat weight readings. They were greater than 2 pounds just in this little sample area. So that's really unbelievable for coat weight. You're not going to get that kind of deviation just in a local area like this. So this tells us we got a lot of error in this lab sampling in this process. So obtaining good lab samples for correlation analysis, it's not simple. There are always many opportunities for introducing variability when you gather the data. So we have to work together to reduce this variability. We means we, ABB, and then our customers. Should be a combined effort. Some of you may think, oh, we have our a field service engineer on site. He's doing everything. No, this should be a combined effort. We work with the lab. Let's get the samples, look at the data, and do the correlation together. Okay, so from a lab test, what we observed, you really need a large sample set, which reduces the effect of random lab and sampling errors. For example, based on the sample size used when the lab did this test, I'll give you the number. It's pretty shocking. 0.1 gram error in the sample weight can produce 1.8 pounds of cold weight error. And then the crucibles that we use, because we had to burn these samples, burn it to ash and then calculate the cold weight. The crucibles, if you have an error in the crucible weight, 0.01 gram error in the crucible weight, that will produce 1.2 pounds of cold weight error. Wow. So it's really critical in this case, to have the right standard operating procedure, and then you definitely, you only conducting one or two correlation analysis using several samples is not adequate to evaluate the sensor inaccuracy here. So what did we do? We look at the process, we look at the sensor, we look at the process, we look at the lab. So this is the area, this is the time we got to think, okay, what is our expected deviation results? So how do you know what realistic expectations you should have in terms of this deviation between the lab and the online sensor? What is achievable? Is it half a pound, 1 pound, 2 pounds? Of course, that's different from machine to machine. So, and when do you need a correlation change? How do you objectively determine this expectation? And set realistic expectations. So in this case, we actually calculated this expected deviation between the online sensor and the lab to be 1.93 pounds here. So then based on that, you draw your upper and lower limits, and this really means if you have the error between the lab and the sensor, if it's within this 1.93 pounds, you don't need a correlation change, because this number was calculated based on the sensor variance, the process variance, and lab variance, and then that's how we calculate this expected deviation. I know a lot of our customers, they just subjectively pull up a number and say, half a pound, that's good enough, that's for our machine. But how do you know? We can help you to objectively determine what this expected deviation should be based on your process. Okay. So in this case, it was really eye-opening for our customer to see that they have a lot of room for improvements. All right, so let's come to poll number 3. How often do you perform sensor correlation? A, we do it regularly. B, we do it once, set it, and forget it. Because some of our customers, they may have a sensor correlation program. They do it once a day, once a shift, or once a week. But some others, they say, we go through all of our grades. Okay, we're correlated. We don't have to do it again. So what do you normally do? Or maybe you will do something different and go into the future. So, we get asked that question a lot. How often should we do this correlation? Or can we do it on one grade and we just transfer all of the correlation coefficients to all the grades? Yep, okay. We do it regularly, and we do it, some of our answers where we do it once and set it, forget it. Okay, thank you. So hopefully, you know, hopefully you know that the sense of correlation is not a one-time deal. Just because there's so much variability in this process. Just like process control. Some of you understand process control. You really need to check your control performance periodically because process changes. So your control modeling should be updated periodically to match your process. That's when you get the best control performance. Okay. Um, so you know, hopefully you during our discussion you remember what I said in the beginning. The online sensor provides your continuous dynamic measurement, but it is influenced by the environment, the source decay, the paper process. So you really need the offline lab to correct the online sensor measurement. So you gotta think about this. Did the process change? Did the lab testing procedure change? The sensor characteristics change? How about use different chemicals on the machine that may affect your paper properties here? Okay, so the sense of correlation should be an ongoing process. Okay, now the frequency that could be different from mill to machine. So, the main really the main thing is you don't set it and forget it. All right. So, you know, we have discussed some challenges and um, hopefully, this is the time that you think about, okay, what are we doing wrong? Do we have a sense of correlation program? Or is there any room that we can improve to get better accuracy? Or we got problems, maybe we can look at all the different areas because we used to think it's only the scanner that's producing this error, but now we got to go back and take a look at our process, take a look at um, our lab procedures. So I pointed out a lot of challenges with correlation, and you may even be thinking about the 400 pounds of off-spec paper you just had to throw away during your because of your correlation issues. Um, so and you're probably also thinking, am I doing this according to the TAPPI standards? Okay. So I just want to let you know that there are solutions to your problems, to your challenges. We want to help you. We want to be your partners to help you to get a good correlation program. If you don't have one, we'd like to help you to have a good correlation program in place. If you have one, what can we do to help you to improve it so that you do get accurate measurements from your online sensors? So we actually have the sensor correlation service. We help mills to choose the correlation method for the individual measurements. You may want to think if you have a tissue mill, are you doing the raw weight or real weight method for your basis weight correlation? And then you gotta think about your lab procedures. You're following the TAPPI standards. Is your oven set to be the right temperature? And how do you have an ongoing correlation program? Because it's not a one-time deal. We talk about that. So in our service, we offer it in 3 phases. Okay, the correlation evaluation, correlation implementation, and continuous verification. So this is kind of like we do a benchmark and a fingerprint to see where you're at. Then we implement results and we help you to have a continuous, certification uh, correlation program. That's the sustain. That's the future. So during the correlation evaluation phase, this is the process that we do a comprehensive study of your existing correlation situation. We even look at the scanners, the online sensors to see if they're correlation capable. Are they repeatable? We perform short-term, long-term stability tests. And then we look at the whole set of check samples. We make sure that the sensor itself is calibrated. We evaluate the existing lab testing methods and the equipment based on the TAPPI standards. And of course, we also want to collect some historical sensor correlation data if you have any. Some of you may be storing this data in your PI system. Okay, let's take a look at the data. See if you have the proper expectations set up and see if you have the proper, oh, another thing I forgot to mention is we look at the grade codes too. We look at your grade code setup for all the different grades because we can just look at your slope and offset to see if these correlation constants are they reasonable or not. So we can do this kind of evaluation. And then based on the phase one, we look at we go into phase two. That's the implementation phase. So we determine the correlation method, the proper, the correct one for each sensor. For example, we use a single point or Ackler bag method for your moisture sensor. What about your sensors in the mid machine, which means it's not at the reel? You can't take samples. How do you do those? Are you just simply transferring your slope and offset from your reel to the size press? That's not really the proper way to do it. Okay, so we'll help you to refine this correlation procedure for your sensor, for each sensor. Okay, at the same time, we'll also determine variability induced by your process variation and the accuracy of the online sensor and the lab test. So our goal here is to calculate proper correlation expectations for your paper machine. This is the part we work together to set that limit. Okay, and then we also teach your lab procedure. We can teach the lab workers, help them to. We follow them. Well, actually, they follow us first. We go through the proper process, and then we watch them and provide recommendations. Okay, like we had to show some paper testers how to do the single point properly. Okay, then based on the results, for the implementation process, then we'll calculate new grade code coefficients. That's the slope and offset. Okay, this is the second process. Then the third one, that's we got to analyze the initial results and provide recommendations for ongoing correlation process. This is a really important step as well. How do you optimize and sustain the results? And you need all three steps to have a good correlation program. Because you think about this, it puts you on the right path to success. It ensures your measurements from the online sensors and the lab closely track each other. So we help our customers to put a program in place to perform sensor correlation the right way. And before I close it out, I said I will show you a couple examples of what kind of financial impact it can have on you if you don't have an accurate measurement. If you don't have, for example, in this case, okay, let's look at the basis weight. So basically, the basis weight sensor was measuring 0.3 of a pound off. So the lab test showed that it should be reading 85.7, but it was reading 86. So this machine, they were basically wasting about 0.3 of a pound. Okay, so what does that conclude? Now, I use some industry constant, for the pricing. Of course, for your mill, you can do some calculation based on your individual situation. So I just use some average. So just by the 0.3 of a pound basis weight error, you can be looking at over $700,000 of savings. Okay, this means you really wasted some energy and fiber that you could have saved if your basis weight was measuring correctly. Okay, how about the moisture? I have a moisture example. So this moisture was reading 0.5% higher than actual. So it was reading, the scanner was reading 0.5% higher, then you got to add more steam to dry that extra 0.5%. Again, based on some calculation, you could have saved $140,000 per year just by having the accurate moisture measurement. This actually was pretty close to what that mill manager told me, that he could have saved $10,000 a month by having an accurate moisture measurement. Okay. All right. So, well, let's summarize here. So we all agree that proper sensor correlation, it improves your quality measurement. Well, I hope you agree now. Quality measurement accuracy, and it enhances paper machine performance. And you will see significant savings in your raw material usage, reducing rejects and energy consumption. And of course, you will reduce your customer complaints. So we have discussed the challenges with sensor correlation and really only touch the surface about this important and necessary subject. This is near and dear to my heart. You can tell I'm really passionate about this process. So the takeaway is that you need to perform sensor correlation regularly, and you need to do it the right way. If you need help, we can help. We're here to help. So talking about help, what can maybe some of you are already thinking, what can we do right now? Well, because of the COVID-19, we cannot travel to your site right now. But there's things that we can start helping you today. So we got a couple services that we can do remotely. For example, this one is a digital diagnostic service. So this is if you already have a sensor correlation program in place. Okay, you need some help reviewing your historical correlation data. If you are doing correlation, you want us to take a look at the data, do some data analysis, and make some recommendations for you. You want us to check the grade code setup to see if we see any issues with your correlation setup. We have a team of specialists. That's their expertise. They can just look at a slope and offset for a particular sensor. They tell you if you got a problem. Okay, so this is one digital diagnostic service that we can help you with. And then what if you don't have a sensor correlation program in place? Or what if you need more help? Well, how about this remote coaching session? So we can talk about how to have a correlation program in place. Or how do you improve your current sensor correlation program? You can't travel to our Westerville office. We actually teach a sensor correlation class there. But in the meantime, what can we do to help you remotely? How about we talk about how to set up realistic correlation expectations? What kind of lab equipment is recommended? We get a lot of requests. So what kind of lab should we buy? The benchtop testers. So how about choosing the correct method for each sensor? And you need help with the single point method. I wish we can do a FaceTime with you when you're doing this testing, where we can spot a lot of errors with the sample taking process. But we even have a video we can show you how to do the single point properly. Okay, so with that being said, this summarizes what we want to discuss today. And now we open up for questions.
Hey, Lou, we did have a question come through the chat window here. And it says, is there a recommendation on how often we should do correlation checks?
Yes. I would like to talk to you a little more about your grade structure and what kind of sensors you have, and then determine how often you should do correlation. If your process is relatively stable, you don't make a lot of grade changes or furnace changes, then you probably don't need to do it as often as some of the others that they make changes all the time. So yes, the answer is that we can talk about that and help you to determine the best frequency.
Okay, one moment, please.
Okay.
Lou, so another question here is, if a mill has an existing program that's believed to be working, but that maybe they're not really positive that it's working as well as it should be, what would it take? How much time would it take to go through that process and maybe tune up that program?
Well, that's a very good question. This is the reason why we offered help in these 3 steps here. Okay, so when we help you, we don't want to say, okay, if I tell you, okay, it's going to take 4 weeks to put you on the right path, I'll be lying. I want to see what you're doing right now first. You think maybe you're doing right, or maybe you're not doing everything right. So I want to help you going in to take a look at your process. Going in, that means either go to your site or let's collect some data first. To help you, we do a benchmark and we take a look at your data, and we'll be able to provide you with recommendations for improvements. So based on what our evaluation result is, we'll provide the recommendation. So I really don't have a set time period to give to you. But we have a process in place. We can help you to get there.
Thanks for that.
You're welcome.
Carrie, if you're out there, you are unmuted if you have a question.
Yes, I do. First of all, Lou, I'd like to thank you. It's been a very good presentation. I think you did an excellent job here of covering this topic. But I do have a couple observations and questions for you. One of the big issues I see is that people, when they're doing the recording of the correlations, they like to record only the value from the sensor and the value from the lab. And that deals with the process values and not the standard values. But to actually do a correlation, you need the standard values. Absolutely. And so what I find people need to go and what I'd like to see is them to have the lab reading, the process value, the standard value, and the slope and the offset. Do you agree with that methodology? Absolutely,
100%. Yes, because at the end of the day, we're really correlating between our standard value and the lab. Our goal is to have the process value matching the lab. That's our goal. But correlation is really between the standard and the lab. Yeah, thank you for bringing that up.
Okay. And one other thing, too, is, and this goes back to the use of SPC or statistical process control. I keep seeing people that saying if we have so many readings that are high or in a line or things like that, at a certain point we'll make a bump to the process. But they don't go back and actually do the actual XY correlation, okay? Mm-hmm. And there were some, you mentioned the QCS handbook, and Steve Stearns was very big on that as far as coming up with rules in there for the doing the correlation. And how do you know statistically if your correlation has changed? Mm-hmm. Mm-hmm. Which is different from the SPC rules that I see most people following. So what is your opinion versus what do you follow? Do you follow the SPC bump procedures, which I think only gets you right on the average? It does nothing about your slope or your range. Or are you using the statistical methods on the XY correlation to make the changes?
Ideally, I like to use the statistical method because you're looking at your whole data range and you're doing the proper coefficient calculation. But I've seen, a lot of the mills just make a quick change and they are really not doing any of this check.
Yeah.
Yep.
Because sometimes that gives you very flat slopes and it affects your profiles too.
That's right. That's right.
Okay.
Yeah. Thank you very much.
Well, thank you.
Okay, we have no more questions at this time. I'm going to go ahead and roll our last polling question.
Okay, we got a last question. I would like to learn more about A, digital diagnostic service. That's the first one I just mentioned here. And B, remote coaching session. If you want to learn more about a correlation program. And then C, other ABB services. Or just anything in general with correlation. Oh, did I show the last? Oh yeah, I showed the last slide earlier with my contact information. So please feel free to reach out to myself or your service account managers or your field service engineers if you have any questions. And we'll be glad to help you.
Might want to go back to that slide, Lou.
Okay.
I think it's just one more to go. There you go.
So there's my phone number. I live in Columbus, Ohio now. Still got a North Carolina number. And there's my email address. So feel free to contact us. And we would love to help you to get on the right path with your sense of correlation. This is just so important for every paper mill.
We'll have a couple more coming in here.
Okay. And I really appreciate everyone's time to be on this webinar with us.
Yeah, Lou, this is Tom. Each mill does have their own account manager, so if you're in discussions later on with the rest of the folks at the mill and you have a question, you can also get a hold of your service account manager that covers your mill from ABB or your account manager. Any of us can get you in contact with the right folks to help you with these challenges.
Yes, thank you, Tom. Yep, or whoever invited you to the webinar.
Okay, I'm gonna go 30 more seconds and then we'll close this down. Anyone still, looks like we got a couple more if you want to finish up, please.
Okay.
So the other thing to mention is we do have a loop tuning webinar tech talk coming up on Friday. If you are interested in that, we can please reach out to Lou or to your service account manager, and we can get you registered for that as well. Or just send a note through the chat here, and we can hook you up.
Yep, and Kevin Starr will be presenting that webinar. If you're interested in process control, you don't want to miss this webinar.
I see there's another question. P.O., you might want to handle this. How does our online testing system help with this? P.O. there?
Please mute. Let me start answering this if you don't mind. So if we have like online L&W or from other manufacturers, online lab tests, that's good for certain paper properties. When I say certain, if you want to get the check, there's, for surface check, for basis weight, moisture, you can get all the check. But if you want very accurate basis weight moisture measurements, you want to use the oven dry method for moisture, and you want to use the proper weight method. Just because if you only take a sample at the end of a reel, if you're not properly protecting your sample, you're not going to get accurate results from the online measurement. Just for correlation purposes. I want to PO if he wants to add something to this answer.
Oh, P.O. says he cannot unmute. I think the other part of that would be that it does help address some variability within the lab as far as the lab procedure. Does it not, Lou?
Yes. Yes, it's very convenient for lab tests, and you can get a lot of paper properties very quickly. But if you want to do weight moisture correlation for the online sensor correlation, you don't want to use the lab online tester.
P.O., you should be unmuted now.
Hello?
Go ahead, P.O.
Okay, in the alkaline, We basically use our standard benchtop instruments that follows TAPPI standards, and the calibration procedures for those modules is the same as the benchtop instruments, if that answered the question.
The main thing is, if you want to get an accurate basis weight measurement, you got to make sure your sample is protected after you take it off the reel. Otherwise, it will condition right away if you don't protect your samples. Okay, did we collect all the answers and answer all the questions?
Looks like it. We have nothing more in the chat window or the Q&A window.
Okay. Well, I want to thank everyone. Thank you for your time, for being here, and appreciate your participation. And again, please feel free to reach out to us if there's anything we can do to help you. And thank you. Have a great rest of the day, and please be safe out there.